Okay, hello everybody. We're going to be talking about parallel lines and transversals, okay? So, first thing we want to talk about is what is a transversal? Well, transversal is a line that intersects two or more coplanar lines at different points, okay? So if you look in the picture down below, you'll see you got a transversal cutting line Q and line R, okay? So, by doing so, you'll notice that T forms a total of 8 angles with Q and R. And these angles and specific pairs of these angles are given special names. Okay, so that's what we're going to be talking about today. So, the first part we're going to be talking about interior angles. As you can see, the interior angles fall in between lines Q and R. Okay, and that's 3, 4, 5, and 6. Our exterior angles fall outside Q and R, and that's 1, 2, 7, and 8. Okay, so interior falls between the lines, exterior falls outside the lines. Okay, keep that in mind because that's how we build these next 3 angle pair relationships. So consecutive interior angles. Okay, what that means, all right, is they are on the interior angles and lie on the same side as the transversal. So our transversals right here, and so 4 and 5 fall on the left side of the transversal, and then 3 and 6 fall on the right side of the transversal. Again, 4 and 5 are on the same side, and 3 and 6 are on the same side as each other as well. Okay, so those are our consecutive interior angles. Our next is the alternate interior. So again, we're still working with the interior. So we're still talking about these ones in between, but we're alternating over the transversal line. So alternate interior angles are 3 and 5 and 4 and 6. Okay, so let me put some different colors on there. So 4 and 6 are in pink. Okay, again, they are alternate interior angles. So they're still interior, but they're on opposite sides of that transversal. Okay. Alternate exterior. Okay, now we're talking about angles on the outside. And so kind of the same thing with the interior, right? So we're looking at the outside, but we're going opposite the side of the transversal. So 1 and 7 are alternate exterior, and then 2 and 8 are also alternate exterior. Okay, let's hold the thought on corresponding angles. I think corresponding angles are easier to see when both lines are parallel. Okay, so let's talk about what it means to be parallel. Well, parallel lines are coplanar lines that do not intersect. We know that, right? Two lines that never intersect have the same slope. And also, it's important to point out that we cannot assume two lines are parallel unless they either give us this information. They say, hey, line JCal is parallel to line LM, or if you look in the picture over here on the right, you'll see these little arrows on the line. I've kind of highlighted them in pink. That's also an indication that the lines are parallel. Okay, so remember, in geometry, we can't assume anything unless we've already proven it or they've given it to us in some sort of theorem. Okay, so in this case, we're going to be going through a lot of those. So down below, you'll see our first postulate. So it says, when two parallel lines are intersected by a transversal, there is a special relationship between the corresponding pair angles, which is what I left out up top there. Okay, so let's talk about those guys. The corresponding angles. Okay, so if two parallel lines are cut by a transversal, okay, so I got two parallel lines. You see the little arrows there, right? Let us know they're parallel. Okay, then each pair of corresponding angles is congruent. So what do they mean by corresponding? Well, they lie on the same side of the transversal and on the same side of lines Q and R. And that's why I said it's a lot easier to pick these out when both lines are parallel. Okay, so if you look at 1 and 3, whoops, 1 and 3 are on the same side of that transversal, right? They're on the top. Okay, and they're also in the top left corner of, let's just give some lines, these lines some names here. So they're both in the top left corner of Q and R. Okay, and what that means is 1 and 3 are congruent, all right, or they have the same measure. Our next one is 2 and 4. Our next one is 5 and 7. And our last one is 6 and 8. Okay? And again, you only get these congruencies if these lines are parallel. Okay, that's why I wanted to point up here. These lines up here are not parallel. Okay, so in a particular picture like this, we aren't getting those special relationships down here like we are with the corresponding. Okay, so just keep that in mind. Unless they tell us it's parallel or we've proven it somehow, we cannot assume that. Okay, so down here they let us know these things are parallel, and so we're getting some real special angle relationships such that we're getting congruent angles out of it. Okay, so let's scroll down here. So let's use the corresponding angles postulate. So it says in the figure, measure of angle 5 is 72 degrees. Find the measure of each angle, tell which postulate or theorem you used. Okay, so let's get these guys out of here, all right, and we're just going to solve these problems on our own. Okay, so let's look at angle 4. All right, well, angle 4 and angle 5 are corresponding. Which means they are congruent. Which means the measure of angle 4 is equal to the measure of angle 5. And so therefore, angle 4 is also 72 degrees. Now it's asking us to find angle 2. Well, angle 2 and angle 4 are what we call vertical angles. Okay, and sometimes it helps to kind of cover up that bottom piece. So if you take your hand and kind of cover up 5, 6, 7, and 8 down below, so all you can see is angles 1, 2, 3, and 4. Okay, you get a nice image of those vertical angles. Okay, so we know that vertical angles, okay, are congruent. So that means the measure of angle 4 is equal to the measure of angle 2, and therefore angle 2, measure of angle 2 is 72 degrees. And if we were to keep going, all right, we'll see that 2 and 7 are corresponding. And so 7 is also 72 degrees. Okay, let's try the guided practice here. So in the guided practice, it says in the figure, right, so we're still using the same figure, just to kind of change the numbers. Measure of angle 8 is 105. Find the measure of each angle, tell which postulate or theorem you used. Okay, so angle 1. Well, angle 1 and angle 8 are what we call corresponding. So therefore, angle 1 is 105 degrees. Now you look at angle 2. All right, so let me zoom in on angle 2. So angle 2 and angle 1 form what we call a linear pair. And what do we know about linear pairs? Linear pairs are supplementary, which means the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And so in order to find the measure of angle 2, I'm going to subtract 105 from 180, which gives me a 75. So the measure of angle 2 is 75 degrees. And finally it says, what's the measure of angle 3? Well, angle 3 and angle 1 are what we call vertical angles. Okay, and therefore angle 3 is also 105 degrees. Okay, Let's go down to a few more theorems and get into some practice problems. So parallel lines and angle pairs. Okay. So alternate interior angles theorem. So if two parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. So what that is saying here is we're looking in between the lines. Right. We're in between those two lines, and we're looking at the alternate interior. So 1 and 3 will be congruent, and 2 and 4 will be congruent, which means those angles have the same measure. Okay, consecutive interior angles theorem. So what this is saying, two parallel lines cut by a transversal, then each pair of consecutive interior angles is supplementary. So what that means is the measure of angle 1 plus the measure of angle 2 is equal to 180. And the measure of angle 3 plus the measure of angle 4 is equal to 180. Okay? So again, they fall on the same side as that transversal, right? 1 and 2 are on the same side, but they are in between. So they're in the interior of those two lines. And then alternate exterior works kind of the same as the alternate interior, right? So we're on the outside of the two lines, and 6 and 8 are congruent, and 5 and 7 are congruent, okay? Which means they have the same measure. And again, these fall on the outside, and they go opposite that transversal line, okay? So 5 and 7, 6 and 8. And lastly, the perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. All right, so in the picture here, okay, they let us know that these two lines are parallel with those little arrows there, okay? And also, it shows that T is perpendicular to A. So what the theorem says, if T is perpendicular to A, then it also has to be perpendicular to B. And that is the perpendicular transversal theorem, right? If A is parallel with B and T is perpendicular to A, then T is also perpendicular to B. Okay, let's get some examples here. Okay, so in this first example, (73 degrees), and I want to find what x is. Okay, so in order to find that, we're going to have to work through some of these things we just saw here. Okay, so this angle right here and this angle right here are corresponding. Okay, so let me put some numbers in there. 1, 2, 3, 4, 6, 7, and 8. Okay, so angle 1 and angle 8 are corresponding. So that means is angle 1 and angle 8 are the same measure. Now in order to find angle 7, okay, I want to take into account that angle 8 and angle 7 are a linear pair. All right? So what are linear pairs? Linear pairs are supplementary, which means they add up to 180, which means that this measure, x is equal to 107. Okay, so I had to use corresponding, and then I had to use my knowledge of linear pairs. So look at the next one. Okay, so I know that 111, this angle right here, so let me put some numbers in there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, based off of our theorems up there, we know that angle 2 and angle 6 are corresponding. So it means 6 is also 111 degrees. So to find angle 7, well, 6 and angle 7 are a linear pair, which means they're supplementary. So 180 minus 111 is equal to 69. So x is equal to 69 degrees. Finally, this last one here. Okay, so sometimes what these problems will do, and you've seen it in the past here, is that instead of giving you a number for that angle, they'll give you an expression, and they say find the value of x. So we have to use our knowledge of what we see in the picture and what we know about these angle pair relationships, and then determine what the value of x is. So in our picture here, L and M are parallel, right? Got our little symbol in there. And then it also shows that T is perpendicular to L, which means all of these are going to be 90 degrees. So if T is perpendicular to L, based off our theorem up top there, then T is also perpendicular to M, which means all of these are equal to 90 degrees. So in order to find the value of x, I need to take this expression and set it equal to 90. By doing so, I get 5x is equal to 135. 5 divided by 135, or by 5 divided by 5, x is equal to 27. All right, and if you were to plug that in, 5 times 27 minus 45, you would get 90. Okay? So, hopefully, it gives you a good understanding about parallel lines and transversals. Okay, you got a handful of homework problems there to go. Good luck, everybody, and be looking for the next video.